Hello and welcome. My name is Frederick Nielsen, and I'm a lead technical product manager in the Unreal Engine. But I'm also an animator, and this means I always try and look at the product from a user's perspective. So we are here to give you guys an inside look into how we made Lego Fortnite and what we went through as a team, both technically and creatively. For the first time, one of our games was fully rigged and fully animated in the Unreal Engine. This is a real milestone for us, and it means we have been able to rethink a lot of our workflows and keep our artists working in the same environment that they're also playtesting in. Joining me here is Jacob Buck, Technical Art Director, and Scott Lemmer, Animation Director. And with that, let's just dive right in. Jacob, why don't you tell us how you got involved in this project?
Yeah, it was just about 2 years ago now when I first heard about Lego Fortnite. At the time, I was on special projects finishing up a talk on destructible vehicles. I was reflecting on my time on the project, and I knew at the time that control rig was the future of rigging. Its node-based workflow and VM for execution opened the door to rigs that I didn't even think were possible before. I really just couldn't see myself rigging anywhere else. Control rig had multiple internal projects pushing on it. It was being used by metahumans, special projects, and Fortnite. I knew control rig was production ready, but I'll be honest with all of you, I also knew that Animation Engine had not been pushed through the paces like control rig had. But Epic is at its best when artists and developers are working together. And Animation Engine really just needed that perfect project to come along. Then it happened. Right about the time I was finishing my tech talk, I was lucky enough to hear about Lego Fortnite. I knew from the start that the project was the project to take Animation and Engine to the next level. The project was perfectly suited for this goal.
Yeah, it definitely was. It was a perfect project. Scott, you want to talk about animation a little bit? How did you get involved in the project?
Yeah, sure. I got involved with the project pretty early on. I was just coming off the Collision event on the Fortnite team when the Lego project kicked off. And the initial scope of the animation was pretty simple. The style really lent itself to proving out a new piece of software for the animation team. As animators, we really loved the style of the Lego movie and how they're using stop-motion animation. We loved the humor that they would put into their choices and how they stayed true to real-life materials of not bending, scaling, or deforming any of their characters. And we needed to test out to see whether or not this was actually going to be possible in Unreal. And we wanted to challenge ourselves to see if we could actually hit that style. So this is actually the very first animation test we did fully in Engine. And this was done by an animator by the name of Ed Fernolds. And he was the very first animator on the project. And with the success of this test, it let us know that it was actually going to be possible to animate in the engine.
Yeah, at this time we were heavily iterating on the rig. I got to work with Fred and Ed quite a bit, just prototyping stuff out. We're figuring out which direction we wanted to go with the face at this time, and we're just building out the initial set of animation tools.
Yeah, it was a really fun time. We were brainstorming what kind of features we wanted in the rigs and what kind of tools we want to build. Even getting to do some animation tests here and there, which is always fun. Scott, I think you brought some tests, right?
Yeah, so these are some more of the early tests that we did in the engine just to explore that stop-motion style. So we were testing gameplay, social sim, even transferring emotes over from the Fortnite characters onto the Lego minifigures. And these tests were successful, but over time, our style eventually evolved. As much as we really loved the look of the stop-motion, we found that as we were play testing the game, people were getting motion sickness, including our very own Jacob Buck. So eventually, the style evolved to more of a fluid animation style. And there was also some other considerations and reasons why we did this. Everything else in the game was running really fast. The entire world and other elements in the game were running upwards of 140 frames a second on high-end machines, while the main player was only running at 12. So we found there was a disconnection in style, and gameplay felt like it was missing some visual information. So the style evolved, and we moved to this more fluid motion style. and that seemed to solve all of these concerns for us. The team really started small. We only had one animator, but the scope of the project just continued to grow over time, and it's a living game that we're constantly updating with new content. More content meant the need for more animators, but to get more animators involved and working in Unreal, we needed to really make sure that we had familiar tools and a familiar workflow to pull it all off.
Yeah, we wanted to create a rig that was intuitive to use. Control rig allows you to make these control rig shaped libraries that allow you to turn any static mesh into a control. This allowed the animators to click anywhere on the rig and just manipulate it. Yeah,
And selecting controls this way is incredibly fast and intuitive for us to select characters and controls with. And every control is just right there at our fingertips. It's right there in front of us. So when we're interacting with the characters, it feels like we're sculpting the pose rather than just like slowly chipping away at it.
Yeah, I hadn't really seen anyone do that yet in Unreal. So, obviously because the characters weren't deforming, it made this much simpler to implement. Whatever we can do to keep the artist in their viewport closer to the characters will always kind of make the tools feel more natural and fluid, right?
Absolutely.
Control rig gave me a flexibility that I never had before with a DAG. What appears like a simple control to animators can contain complex rig logic under the hood. And the result of that is that you end up with a rig that's not only easier to pose, but it's also intuitive to use.
Yeah, and even though these controls were simple, they actually gave us some really advanced ways to pose that were completely unavailable to us with other software. Yeah, and they're actually set up in a way where it stays really true to the real-life materials that the minifigs are made out of, and it also helps keep our characters on model.
Proxy controllers were another eye-opening moment for me. They are non-keyable controls that allow you to manipulate other controls. Since these proxy controls fire in their own event stack, you can create complex manipulation by just rotation. In the case here, we have what I call the body rocker. Every tick, the proxy controller calculates the pivot to use and is able to rotate and translate the body around that pivot. Proxy controllers were a really big part of removing complexity from the rig.
Yeah, and instead of having to rely on these custom controls that would deal with temporary pivots, these proxy controls actually gave animators access to multiple pivots that were built right there into the rig. So posing the characters actually feels like it's actually like interacting with solid surfaces and makes creating convincing contact fast and easy for us to achieve.
Yeah, this was such an exciting time for development. We really started to feel the power of what we could achieve in here with these control rigs. And it felt like we were charting new territory, and our heads were exploding with all sorts of ideas on how we can use these new features.
And with having locked down the animation style, in addition and combination with these new rig tools and features, it actually really made it super compelling and exciting to be animating a full game in Unreal.
Actually, I kind of remember that story a little differently. Scott, you called me up and you were like, I don't know, are you sure we can do this? Is the tools ready?
Yeah.
Can we handle this?
Yeah. Initially, we were pretty hesitant, I'll admit. We already had existing software, tools, pipeline, workflow that we were comfortable with and that were working really well for us. So we were really wondering if this was going to be possible and better than what we already had. And we knew if this was going to work, we needed to make sure that we addressed some of these initial concerns.
Yeah, absolutely. Since we knew what the animators needed to do their jobs effectively, and then we started taking a closer look at the scope of the project and the deadlines, it honestly made me a bit nervous as well. But we always went back to what Jacob said earlier, that there's no better suited project than this. There really wasn't. So Scott and I chatted more about the plan, moving forward and how we could best support this project. And we went straight ahead.
Absolutely, yeah. And we knew that for this to actually work, it had to be a comfortable and just seamless transition for any animators coming from other software. And fortunately, after talking with Fred, a lot of those concerns were smoothed over. And we realized with the continuing development and new features that were on the way, we just felt a lot more confident and optimistic that this was going to work out.
So this project quickly became our top client for feedback to both the rigging tools and the animation tools. We gathered lots of feedback from the animators. What kinds of meetings do we have to put into place? What kind of Slack channels might we need? How do we handle onboarding? So first we focused on quality of life and some of those initial pain points that the animators were feeling. Even simple things like selection and manipulation and missing hotkeys, that kind of stuff. So first we then started working on improving some of the other tools, like more advanced kind of tools, space switching and constraints and snapper tools, even some of those tween sliders that the animators would be used to coming from other tools.
Yep.
I remember several meetings with Scott and the animators where they were a bit frustrated because I'd demo all these fixes and new features, and they knew they wouldn't have them yet because obviously a project of this size, we had to be pretty cautious on taking big new engine updates. So how do we solve that? Well, we ended up moving some of our development efforts directly onto the game, and this meant that the animators had quick access then to some of these fixes and new features, and that made the world of a difference. But this obviously came with its own challenges because things could break, and they definitely did. But when issues came up, we quickly pivoted, and we were able to kind of fix things pretty quick. So.
Yeah, there was so much work to do and just not enough people to do it. So we took a two-prong approach to get the tools out to the animators. The art team on LEGO Fortnite worked very closely with Fred and the engine team. We divvied up the efforts. Core provided new functionality, and the art team focused on building tools for interfaces and workflows.
Yeah, our appetite definitely far exceeded what we could achieve in time, so this was really the best approach moving forward.
Luckily, Unreal provides intuitive frameworks for building tools and creating rigs. Control Rig and Blueprints both share a node-based interface and will be familiar for anyone trying to learn them. Editor utility widgets are at the heart of building interfaces in Unreal, and I feel that so many people just do not understand how powerful they are. They make building interfaces accessible to anyone that knows Blueprints. We know pipelines are very specific to studios, and editor utility widgets allow a studio to build a pipeline tailored to their workflow.
Yeah, whenever we add any kind of new feature or functionality to the engine, we also always have the ability to expose their API. So tools like these can be built around them, to either automate or script how they're being used.
Kind of to highlight some of the power of these editor utility widgets, I want to show you a couple tools. Animators needed a window into all their data that they were going to create in the engine. The animation browser was created to give animators a central place to view and open their animations. We also wanted to tackle file management. This tool took the guesswork out of naming and organizing files. It even has a built-in versioning system, so every time an animator saves a file, it gets put into a repository that they can recall later. This tool was fully built with Blueprints.
Yeah, and file management is very different for animators. So getting the Anim browser was a crucial tool for us as animators and getting those animators into working in the engine. When they're working in the engine, it actually helps us out a lot because they become a lot more familiar with the systems and how everything's implemented. And it also gives them a better understanding how it all comes together, and as an end result, we get much better animation.
Linked anim sequences were also critical to our workflow. When animating a character in a level sequence, the animation data is automatically baked to an animation sequence on save. This provides a seamless workflow for animators who just save their scene, and the animation is automatically updated for them in the engine. The animation browser took full advantage of these. There's another utility widget I'd love to share with you all. This is an animation picker that was built on LEGO Fortnite. This modular picker was designed to make animators feel at home. Under the hood, it allows any artist to take the full power of Blueprints and build a custom picker for any character or creature you would like. But it also allows animators to customize the picker and the widget itself. It exposes quick access to handy features like mirroring and flipping, and it also provides access to Unreal's built-in pose library.
Yeah, and the fact that we could now pan and zoom and marquee select all the things that animators are used to be able to do We could customize the picker. We could add buttons to our liking. And it made it really familiar. And having the picker, as well as the easy file management, that actually kind of unlocked the door to being, really accessible for animators animating in the engine. Anyway, there was still a lot of work to do. Even though we got some of those tools out of the way, we were animating an entirely new game from scratch. And another huge initiative we had was we were supporting Fortnite emotes in LEGO Fortnite. And this was an interesting and challenging process because minifigures, as you can see, have very different limitations than a humanistic character. They've got different proportions. They don't have elbows. They don't have knees, wrists. They don't even have fingers. So it was far from just like an easy, seamless one-to-one translation. We had to come up with actions that would have the same intent and feeling as the Fortnite characters. But on top of that, we also had to make sure that our animation worked with many different outfits that Fortnite had to offer.
As Scott just said, Fortnite has a large catalog of outfits. We're in the process of converting them over to LEGO. To build out such a large set of outfits, we're using Mutable to combine the meshes and textures at runtime. To bring all these outfits to life, we wanted to minimize the amount of custom animation needed for each outfit. The minifigures share one animation set, and to get variety, we are using runtime control rigs to procedurally add it where needed.
Yeah, and since it's all working at runtime, and they're all sharing that same animation set, it means we can test and iterate our animation using any outfit we want.
For the face, we took a texture-based approach. Before landing on this, we experimented with a wide variety, but we ultimately came back to textures. It's performant, it stayed true to the materials, and it supported that snappy style of animation that we were going for. This also had the added benefit where we could just swap out the face atlas and get a different outfit pretty quickly. We're using a total of 120 animation curves to drive material parameters, so the system is material agnostic. At the heart of the material, it's just transforming UV space. And because of this, we can get a rig working across a wide variety of models, such as Peely. We even implemented a UV warp that could liquefy parts of the face, but we ended up not needing it because the rig was flexible enough without it. Certain outfits also have the ability to enable a runtime control rig, which procedurally animates the beards and the mustaches. To do this, we're taking advantage of control rigs' data-driven approach. Using data assets, we are able to embed data on a skeletal mesh and read that data back into the control rig. This is incredibly powerful. When you combine external data with the ability to procedurally generate controls based on the incoming hierarchy from the skeletal mesh, you can create a flexible control rig on any mesh that's placed on. A simple example of this is how we're using a single control rig for the vast majority of the props on LEGO Fortnite. Control rigs were also being used at runtime on our creatures. Quadrupeds present an interesting challenge when walking on uneven terrain. To get the creatures to adapt to any terrain, we're using traces to detect the ground plane, and then we're adjusting the way the creature behaves on that terrain. This allowed us to adjust the chest and hip position based on where the feet and the head are at any given moment. We also leaned on control rigs' built-in profiler to make sure that these rigs stayed performant at runtime.
Yeah, it's been incredibly powerful for us. Slope warping has meant that it eliminates the need for any custom blend spaces or pose content that otherwise we'd have to provide.
So I want to put my product hat again and highlight some of the cool new stuff that we've been working on lately in 5.4, especially around animation authoring. So we've been working on new gizmos. So these are our manipulators. They're still experimental, but they're available for you all to try in 5.4. They have a new look and a style, and they also have a new feel. The proper indirect manipulation. They have a new parent space option in the viewport. So previously we only had local and world, so now you have parent. We've also done quite a few improvements to our sequencer, so where we not only improve the look and style of it, but also a lot more flexibility in how you can customize kind of what's available to you. Things that were hidden deep in like right-click menus are now exposed as columns and icons right next to the tracks and stuff. Our anim details, so this is our channel box. The previous version only showed transforms on like characters' controls, but now we've centralized showing transforms on anything that you may have added to your sequencer, including props, cameras, lights, as well as those character controls, of course. We've added a new selection system to the anim details window, which is fully synchronized with your curve editor. And we've fixed issues with just using those sliders in like the details view. This would be our anim details, but yeah, just kind of more functionality around that. We've added key status indicators, so you know if you have a keyframe on the current frame or not, and definitely more to come in this area. Our curve editor, so our sequencer curve view, we've also done quite a few improvements there. We continue to focus on quality of life, and we've been working on the performance of it. We've improved zooming and panning workflows, selection accuracy, even understanding like awareness of what curve type you're animating in. So keys before, it'll kind of analyze what curve type it was and continue on with that. Our constraint system has also been really overhauled. We rewrote the data model to save just into the level sequence for any constraints that you may have animated. But we also still support level constraints when you're not using the sequencer. We've reworked our evaluation engine to better handle more complex, like nested setups. And you can now even change settings on those constraints on creation. So you can turn off maintain offset or even constrain individual axes now. We have a new system that we're pretty excited about called layered control rigs. And this gives you a lot more flexibility in how you pose and animate on top of incoming data. So we're already using them in all sorts of interesting ways. It means you don't have to bake data down to the control rig to modify it. You can just add a layered rig and then just animate on top of it. We're super excited about these and getting your hands on them and seeing what you all do with them. They're pretty cool.
Yeah, and all of these updates are incredibly important. I mean, if we didn't have them, it would be impossible for us to fully commit to animating this game in Unreal Engine. And having all this work that has been done in one piece of software allows us to do this and animate in-game without any round tripping.
The rigging and character authoring side of the engine are also getting some big updates in 5.4. The ability to author a character in one place also has massive impacts for predictivity. Chase Cooper will be at the Learning Theater in Epic's booth running through all sorts of awesome rigging demos. Please go check them out.
So these are just a few highlights of some of the features that we are excited about in 5.4, but we've also made tons of other fixes and improvements. 5.4 Preview 1 is available today, so download it, play with it, send us your feedback. We do want to hear from you. Speaking of new features, Scott, I heard one of your animators found a pretty cool new workflow, happy accident.
Yeah. So actually, before I tell you what that is, let me just set up our workflow to give you an idea of what it was like up until this point. And as fantastic as it was to put aside the third-party software and completely animate in the engine, we're still slowed down a little bit by having to launch the game in Pi anytime we found something that we want to iterate on or fix. And what we would have to do is close down the game simulation, work on our animation, save it, relaunch Pi, wait for it to load, and then reset up the ability or whatever it is that we wanted to test. And it was still a process that would take several minutes sometimes. So what happened was one of our animators, Nick Beckstead, was animating away, adjusting poses and timing like he would normally do as he's working on his work. But he had found that he had unintentionally left the game running in the viewport. But he realized that his changes were already updated in the game. And we had discovered at that point that we were able to work and animate without ever having to leave Pi. So all of that back and forth was completely cut out. And we can now animate and play test our results instantly. And any of you that have worked on gameplay animation before, you'll understand just like how valuable that is to be able to animate and just see the results. You can play test the results instantly in game. And for animators, the seamless workflow is really just absolutely mind-blowing.
I wanted to thank you, Jacob, and your fabulous tech art team, and Scott, your animators, for being patient with us as we go on this journey together. And of course, our amazing engineers, both in the control rig team and the sequencer team. Obviously, we couldn't have done anything without them. And next up, I want to introduce Patty Walker to the stage to talk about motion matching. Thanks, everyone.
Thank you, guys.
Hello, everyone. Thanks for being with us today. I'm Patty Walker, Technical Product Manager of Gameplay Animation. With me is Samuel Rigamonti, Principal Engineer on Motion Matching's development, and Jose Villarroel, Lead Engineer of the Gameplay Animation team. We're really excited to talk to you about delivering motion matching to everyone, and we'd like to give some insight into some of the challenges and solutions we came up with as we ship motion matching into Fortnite and Unreal 5.4. Now, before I dive into all of the challenges, I want to start with some positive news. Fortnite Chapter 5, Season 1 officially shipped with motion matching running on all 100 players, all NPCs, and on all platforms, including Switch and mobile, which is something we're really, really proud of. Now, with that said, let's jump right into the challenges. Fortnite ended up being one of the hardest examples to get right with motion matching. Why? I actually originally thought the opposite. Fortnite prior to this only had 8 cycle loop animations. The entire player set was pretty tiny. How hard could it be to recreate that? It actually wasn't that hard. But we weren't trying to do just that. This is how a lot of people play Fortnite. It's a Twitch shooter with instant responsiveness. It's got 2 frames from full speed to full stop, fully networked with 100 players and NPCs. It's established as one of the biggest games on the planet. And this feature was built by a small dev team with a short turnaround time. Most of what I just listed are areas where motion matching traditionally struggles to get to quality. And our goal wasn't to deliver the final version of animation quality that could be achieved, but instead create a framework where it started on a strong foundation that could continually improve into the future. On top of the struggles of just generally making a Twitch shooter look great, we also had some challenges early on with Unreal's foundation as well. Because Fortnite is completely capsule authoritative, brute motion wasn't an option to use to get back animation quality where we needed. Our default movement model in Unreal, the character movement component, is a bit rigid, and it wasn't as customizable as we needed it to be. And we lacked internal animation data and resources to help push and test the scalability of quality in the system early on. Then there were existing features in Fortnite itself that could greatly complicate how we used motion matching. Items like Icy Feet, where consuming this item makes the character slide around as if they're on ice. Or Hot Pepper, where the character's acceleration increases exponentially after consumed. And finally, Fortnite Creative, where users can manipulate the speeds and many aspects of the movement model on the fly to nearly whatever they want. Now, let's use Icy Feet as an example. This is what happened right out of the box when we tried it initially. As you can see, all of a sudden, motion matching got really confused on what to pick, with no data matching now what was being requested by the movement model. So, not so great. But it wasn't just existing features that we had to battle with. For Chapter 5, the Fortnite team introduced a giant moving platform, the train. And, like with the Icy Feet example, our motion matching solution didn't exactly work just out of the box. It became clear quickly that the train's velocities were also being piped into the player's capsule, causing a complete breakdown of selection or the idea of direction and speed. Now, on top of all these game-centric and Unreal-centric challenges, the system as a whole had to be extremely performant, memory-conscious, and simple enough for artists to use. It needs to scale to anyone's vision of how they wanted to use motion matching for their games. Right, and then the classic game development problem. While we've been developing motion matching in Unreal for some time, putting it into Fortnite wasn't initially on our list, nor was the timeline on our side. However, upon showing Fortnite our internal prototype, they got pretty excited and wanted to see it in the Chapter 5 release. This left us with about 3 to 4 months of development time and a few weeks of iteration time, which was not a lot. So, I've laid out all of the challenges that we kind of ran into. We had a lot of work to do. Now, I'm going to hand it off to Sam to chat about some of the solutions that we came up with. Sam?
Thanks, Buddy. Now that we understand the challenges we faced while developing our motion matching solution and the additional requirements specific to Fortnite, let's dive into the recipe we deem necessary, starting with some fundamentals. So let's add some context and terminology we can reuse later on. Motion matching is an animation technique that automates the transitions between nodes of a motion graph, where the nodes are sample poses of animation from a database, and the selected transition is the one that scores the best given a metric between two poses, where one of them is the query pose. In our implementation, the simplest setup consists in a character with a movement component running an animation blueprint with a motion matching node and a pose history node. The motion matching node will search a given database using a query constructed from historical information from the pose history node and a motion model prediction from the movement component. If the search selects something other than the continuing pose, defined as the pose that comes as a continuation of the previously selected animation asset, the motion matching node will perform a blend into the newly selected animation asset, repeating these cycles every frame. With this understanding on how the matching is performed, let's introduce the database schema, the asset defining the metric between poses, and specifying what we care to match. For example, the character fit positions and the future trajectory, and how much we care about those features via their weight. We define the schema as a collection of channels, simple building blocks, to match positions, velocities, headings, and phases, composable in more complex channels to match trajectories or entire poses. With the basics out of the way, let's continue our dive into the Fortnite motion matching recipe. Because of Fortnite's tight memory budget, we decided against dense cards. And instead, we started with well-crafted short animations with higher connectivities for those pose features we wanted to match, like character fit positions and velocities, to facilitate the motion graph's automated transitions. We also organize our animations in multiple databases driven by gameplay logic to discern pivots from start-stops, idles and run cycles, as well as being able to differentiate high-ends from low-end platform setups. But ultimately, we had little data that sometimes poorly matched our twitching motion model. We knew we needed to construct motion matching queries that better reflects the manifold of our sample animation poses. So we started with manipulating the input trajectory generation by remapping motion model velocity and accelerations, as well as doctoring rotation rates and filtering out spamming input behaviors. For moving platforms, Icy Fit and Hot Pepper, we had to reconstruct historical trajectory and character pose informations to support moving reference systems and transition between them. The high frequency of animation shredding caused by motion matching in the context of a Twitch shooter put high stress on the inertial blend we initially adopted. Inertializing continuously between non necessarily similar poses was causing visible extrapolation defects, like ripples in trajectories of fast-moving limbs, so we introduced a simple blend stack implementation. Blend stack is an anim node in charge of playing animation assets until their blend weight fades away, implementing a proper dynamic interpolating blend tree used by motion matching during asset selection. We then use procedural behaviors to mitigate the discrepancies introduced by our doctoring between motion model and query, as well as the discrepancies between the query and the selected animation caused by the lack of animation coverage. A mix of stride warping and play rate scaling were used to compensate differences between the capsule and the selected animation speeds. Blend profiles with faster blend speeds on the character lower body were used to mitigate fit sliding during blends, and orientation warping helped bending the selected animation towards the requested input trajectory. And for better result, we leverage blend stack graph support to perform orientation warping on every animation in the blend stack prior blending them together, as you can see from the multiple green debug lines in the video. The final touches to the setup were made by tuning what we call continuing pose bias, a cost discount for poses playing as continuation of the current animation that allowed us to reduce animation shredding by sticking with the currently playing animation as much as possible. We also added block transition notify states to prevent jumping into sections of animations that don't play just right unless played from the start, like drastic turns or jumps, where you would never want to pick a pose after the character has left the ground. For specific assets like looping animation, we disable reselection of poses from the same asset, and we added a ring buffer, keeping track of previously selected poses to avoid repetition of past choices that would make it look less natural. And this is what we ended up with. And now I'll hand it off to Jose to talk about layering.
Sam gave us the recipe for high-quality motion matching. Now let's talk about layering and why it is a crucial part of developing a scalable pipeline in a live service game like Fortnite. We had to rework how all of our items were structured. This meant hundreds of weapons and consumables had to be rebuilt to use motion matching. For some context, before Chapter 5, Fortnite used per-item additive animations. There is one base animation set, and for each distinctive item, we manually author roughly 14 additive animations. Using motion matching, we can have hundreds of individual animations. So we ran into two challenges. One, we simply could not author hundreds of additive animations per item in the span of a season release. And two, even if we could, how do we fit this in memory? It became apparent very early on that to scale, we needed a runtime procedural solution. We used Fortnite as our R&D space. The first step was to reach our animator's quality bar. This graph is a simplified version of our prototype, but it shares the same core pieces from our approach. First, an unarmed animation selected by motion matching. Second, a frame of an unarmed idol to build a dynamic additive from. And finally, a static per-item pose to layer on top. We also had two custom nodes. First is Bone Mask, a dynamic layered blend per bone node that is data-driven. And second, Copy Motion, which extracts an additive transform of a specific bone and allows you to scale it and reorient it before applying it. This screenshot is from an earlier version of our approach, where we baked these curves offline. But we switched to our runtime approach, supported by motion matching's pose history that let us dynamically delay the resulting curves in time. We could also tweak and edit the values on a per-item basis. Let's see how that looks. As you can see on the middle clip, the additive on its own was good enough for the body, but the arms looked very stiff. It was impossible to use the hand motions as is, because they're in the wrong direction. Using copy motion and pose history, we could reorient and delay the curves by just a few frames. This allows us to make heavy items feel weighty entirely at runtime. Finally, we apply this motion curve to our hand IK effectors and elbow controls. The next natural step was to apply procedural layering to a variety of motion match animations and see if the system holds up. These animations are from an early internal test, but the results were very promising, and it gave us confidence in the power of the layering approach. After this, we completed our setup, and we were entirely data-driven. We tied all procedural, all layering parameters, and even static poses to data assets. Animators could swap out and tweak values live using proxy tables and choosers. Shortly after, designers and animators were using these tools in ways that we didn't expect, by tying parameters to arbitrary gameplay behaviors. This culminated in the ballistic shield, where an animator was able to animate a complex item in only 1 hour, and with only a few poses. With this, our content pipeline felt solid, and we started production and conversion of all of our items. The next step was tackling the performance and memory challenges. Using choosers, we separated our motion matching databases into a dense and a sparse set. Our dense set had hundreds of animations, and our sparse set had less than 100. Thanks to improvements in the animation compression library, we saw savings of up to 16%, and we were able to fit the sparse set on the same budget as the previous system, including an additional slow walking set not present in previous seasons. As you can see, a dense set is much higher quality than a sparse set, but the sparse one still holds up pretty well, thanks to post-warping as well as time scaling. Unfortunately, last-gen platforms were still over budget, but we knew we wanted to bring the dense motion matching set to the widest possible audience that we could. And so, we began our optimization process. At this point, our new system was almost twice as slow than the previous season was. Our new nodes performed reasonably well. We could do better, but even untouched parts of the anim graph were slower than ever before. We recently introduced Fortnite to post-warping, dead blend, choosers, and organized our setup into more subgraphs, among other things. This degraded performance and memory in unexpected ways, and we had a death by 1,000 cuts situation. There was no obvious single culprit to the performance problem. So we had to optimize everything. Our teams worked really hard in a variety of improvements to memory and runtime performance in various animation systems. These will be mostly available to you in 5.4. The animation attributes one was significant to us, so if you use them in your project or if you use post-warping nodes along with root motion, be sure to give this a try. And finally, after optimization, our performance numbers were similar to previous seasons, but with more post extractions, more animations, and with motion matching as the cherry on top. But last gen was still 15 megabytes over budget for the dense set, and we were really, really close to reducing the number of animations in some of our most popular platforms. And then Jason Horner submitted this random change list that replaced a single line of code that costed us 17 megabytes. It's in the layer blend per bone node, so if you use them, this change is included in 5.4, and it will save you a lot of memory. And with this, we finally shipped. However, separately from the motion matching implementation, Chapter 5 shipped with additional movement model updates that were not well received by the community. Movement speed was slightly reduced, and the animations were already authored to match that. The Fortnite team reverted these movement changes, and we were impressed with how quickly motion matching let us adapt to it. We added 5-run loop and 5-run start animations to restore the style of previous season runs. We dropped them in our database, and it just worked. Then for all of the weapons of the chapter, we also tweaked all of our layering data assets to match the new run style. This would have been unthinkable in our old system. And with motion matching and layering, we did it in just under 2 weeks. That brings us to where we are today. We have higher quality animation. Thanks to motion matching, we have faster, more flexible layering workflows for item authoring. And using both, we have a future-proof system to power Fortnite in the years to come, or until something better comes along. That concludes the story of how we brought motion matching to Fortnite. I'll hand it back to Patty so that he can share how we're bringing motion matching to you.
Thanks, Jose. Now, let's talk about motion matching for you, for your game. Motion matching will ship in Unreal 5.4 as production ready. And on top of this, shortly after 5.4, I'm talking a few months, we will also release a learning project that will have everything you need to get up and running with motion matching. Whether you're AAA or indie, we want motion matching to be accessible to you. That's why this project will not only be well-structured and easy to understand, it will also come with hundreds of animations available to you for free to kickstart your projects or pre-production. This is why it's going to take us a few extra months post 5.4. Please bear with us. I promise you it will be worth it. Here's another look at what was shown during the State of Unreal. This is the foundation for the sample project. Everything shown is full gameplay with no custom code. We also want this project to continue to evolve and expand over time, delivering more features, more animations, and quality for everyone. We will have more information on this very shortly. To us, this is just the beginning of motion matching in Unreal. We still have lots of features, workflow improvements, and ideas we want to try, to develop, and to deliver to everyone. Here's a quick look at some of the areas we've talked about expanding into. Root motion control and networked root motion solutions for teams to use. We'd like to use motion matching to generate content-driven blends. Multi-character motion matching. Our plans for this focus around combat initially. Better tooling around generating and manipulating trajectories in the engine. More tools for artists to match their source data to the movement model. And of course, constant improvements to workflow and ease of use, plus much, much more. And finally, a shameless plug for the team that put this all together. So go check out motion matching in 5.4. Thanks, everyone.